Hello everyone. Hope you are learning a lot in your life each and every day. You are watching Code with Shubhajit. So today we will be understanding the count and say problem from Lead Code, which comes in the medium series. So let's get started. Let's understand the problem statement, what they're trying to say. So the count and say sequence is a sequence of digit strings defined by a recursive formula. Okay, they have initially mentioned recursive formula. So count and say of 1 is 1 only. So this is the base condition. Now, count and say of n is the run length encoding of count and say of n minus 1. What is run length encoding? I will explain you with this example. That would be better. Okay. So here you can say when someone asks for count and say of 4. Okay. So let's say we have this count and say of 1, which is defined. Okay. Count and say of 1 will be 1. Good. What is count and say of 2? Count and say of 2 will be RLE of 1. That is the previous count and say. Okay. So basically count and say of 2 is RLE of count and say of 1. Same way count and say of 3 is RLE of count and say of 2. Okay. We will understand what is this hopping back and getting the result and pushing it to the front. What this is actually known as. So here when we want to find the RLE of 1, we have to see that for whatever characters we have, what is the frequency, consecutive frequency and the character itself. So this RLE of 1 will be represented as one time 1 has occurred. One time 1 has occurred. Okay. Now RLE of 1 1. This is the last one which I will take for accountancy of 3. So 1 1. It means 1 is occurring 2 times. Okay. So it is 2 1. 2 times 1 is occurring. Now RLE of, sorry, accountancy of 4 will be RLE of 2 1. What it says? It says that okay, 2 and 1 both are different numbers. In that case, it will say okay, one time 2 occurs, one time 1 occurs. So can you see one time 2 occurs? This is for the initial first 2 and then 1. The next one says one time 1 occurs. Okay. If you are not able to understand, still it's fine. I will explain with larger examples in the OneNote, so not to worry. But you should understand how the larger elements are being calculated with the help of the smaller elements. Okay, so let's say if someone says us, okay, find count and say of, I am taking the count and say as CAS, short form for faster writing. So let's say if someone says what is count and say of 6, so I have count and say of 4. What is that? That is 1 2 1 1. Good. That is 1 2 1 1. Now we have to find what is the count and say of 5 before calculating count and say of 6. So what is count and say of 5? So can you see that 1? There is no 1 after that. 2, which is a different element. So that's why one time 1 occurs. Now we have a 2. There is also not a consecutive 2 just after that. Okay, or more than 2 times it is occurring. It's not that, it's a single element. So 2. So one time 2 occurs. Now we have a digit 1 which is occurring 2 times. So that's why 2 times 1 occur. I hope this you are able to understand. Now CAS of, if I have to calculate 6, which is RLE of CAS of 5. So RLE of this basically. So 1 is occurring 3 times. So what I will say, 3 times 1 occurred. Okay, this part is done. 2 is occurring 2 times. So 2 times 2 occurs. Now 1 is occurring 1 time. So 1 time 1 occurs. I hope you are able to understand this. Okay. Now for larger values as well, we can go on and on and on. But you should understand that how for calculating CAS of 6, we need CAS of 5. For calculating CAS of 5, we need CAS of 4 till the point CAS of 1, which has a predefined value of 1 only. So this logic or this algorithm where we need to find the previous element with the same function. So can you see the pattern? CAS of n is RLE of CSA of n minus 1. This is the logic. So whenever we have to call a function, again for calculating the present function, this is called recursion. This is called recursion. Okay. And in the problem also they have said this is a recursive type of logic. So that actually revealed the logic. I would be explaining it anyway, but yeah, now you should be able to understand that how it is recursive, because the same method for calculate, because the same method with a parameter needs the method again to be called with a different parameter. So that's why recursion happens. Okay. So layman example or layman terms, when a function calls the same function, that is recursion with a different parameter. Because if it doesn't call it with a different parameter, this will go on an infinite loop, which we don't want. That's why we have a base condition of CAS of 1. So when we have a CAS of 1, we will not go below that. CAS of 0, CAS of -1, no. We will return a 1 in that case. If I take the CAS of 5, now we have to calculate CAS of 6. How will you devise the logic? That is the most important thing, right? Okay, for calculating CAS of 6, you will be taking an empty string. But before that, you have to first calculate CAS of 5. When you got the CAS of 5, this one, then you will have some operations over it which will give you CAS of 6 over that. So when you will go through this loop, when you will loop over this string, you will check that what all consecutive elements are coming for me and what's the frequency of them. So here, let's say if I have a pointer I, let's say if I have a pointer I, okay, I'm just telling you the actual coding part what I will write. So we have a I pointer starting here. We will take a j on I plus 1. So I will take the j here, which is I plus 1. I will index them out. Can you see that when I is at index 0, j is at index 1, I will loop this j till the point I have the same element as I. So j will come here. It's still the same as I. Now j will come here. Now at this point, the internal j loop will break because j is standing at a point 2, which is not same as the element which is at I, which is 1. So in that case, it will break and it will check that's what is the difference between I and j. What is the difference between I and j? So the difference between I and j is actually 3 minus 0, which is 3. So I understand that there are 3 same characters consecutively. And what is that character? That character is whatever is present at I. So when I will write CAS of 6, I will write it as, so I will write 3 times 1 occur. Okay, good. And now I will actually go to the point where j is there. So now I will be pointing to, I will take it as a different color. Now I will be pointing to this where j is pointing only. Now I will make the j to I plus 1. What is that? That is here. Now again the same thing will happen. Now j will go to the point till it is same as the element at index I. So now it is same. Index 4, the element is 2. Index 3, the element is 2. They both are same. So j will increment to the index 5. Okay, now I have 1, which is different from the value at index I, which is 2. Okay, I will calculate, okay, what is j minus I? J minus I is 5 minus 3, which is 2. It means for 2 times, the frequency is 2, a character has occurred consecutively, which is the element character which is present at index I, which is 2. That okay, 2 times 2 has occurred. Good. Now I will move the I to where our j was there. So j is there at the last. So I will move I to the fifth index, index 5. Okay, so I is pointing at the last index. Now j will be I plus 1. Now j is actually 6. But 6, there is no element. J is out of bound. So when j is out of bound, so that internal loop will break. I will come out and I will check what is j minus I. J minus I will be 6 minus 5, which is 1. So now I know that, okay, one time the element at I, which is 1. So one time 1 has occurred. So this is CAS of 6. Let's go to the coding part. Hope you are able to understand this. If not, please watch this again. Okay, so starting with the code part. As we know that this count and say is a recursive method, right? So here we have to define the base case at the start only. So when n is 1, what I will return? I will return the base case which has been mentioned, which is 1. Okay. Now when the base case ends and n is not 1, in that case, what we will be doing? We will be first calculating what is the string which we are getting with the recursive call, which is calling the same count and say method with n minus 1. So can you see that inside this count and say we are again calling count and say? So that actually makes it recursive, but with a reduced count. So that at certain point, the loop, the recursive calls will end. So the recursive calls will end when n reaches to 1. Okay, good. So whatever RLE string which we are getting from count and say of n minus 1, on that we will find again one more RLE to get the count and say of n, and we will return that. Okay, for that, okay, so I have taken a new RLE string which will actually calculate the RLE for this count and say of n minus 1. And I have taken this as a string builder because here we will be adding more and more or appending more and more elements to this new RLE str in the while loop. And I can actually do this as well. So I can actually do uh, new str is equals to this. This can also be done. This is totally fine. But why I'm using string builder is your homework. Giving you a hint that string builder is better when we need to update the present string a lot of times because of string pool, which this thing uses. I have given you a lot of hint actually. So it is basically to optimize the memory a lot. And at the end, I will return the new RLE str dot to string. As my return method is string, that's why I need to convert this new new RLE str, which is a string builder, to string. Okay, so this will take care of that, this toString method. Okay, now the actual logic comes. So if you see here, that when we are going to calculate CAS of 6, we need to find the RLE of CAS of 5. And how RLE is calculated? RLE is calculated with looping over the whole string, okay, and then finding that what is the frequency of each of the elements and then appending into the new string. So the same thing which we will do also. We will have a pointer as I, which is initialized to 0, while I is less than the size of this one. So what it will be? Let's store it in a variable only, right? Int sz is equals to RLE str dot length. Okay, so here I am storing it. So while I is less than sz, okay, because I don't want the I to go out of bound of the loop, right? Okay, so inside this, if you remember, we will take a j which will check that whatever element we have at index I, till how much it is going, or what is the frequency of the consecutive elements till which the same element at index I is present. Okay, we will be looping over with one more while loop which says j is less than sz and RLE str dot caret. I will just tell you what I'm doing. So till the point j is less than sc, this is the breaking condition, and the RLE str dot caret j is double equals to RLE str caret I. It means that if I show you here, did you remember that I was here, j was initially here at index 1, and till the point j is actually equal to the element at index I will make j plus plus j plus plus till the point. Okay, so this is the block which will be handling that, this block. Okay, I hope you are able to understand that j is less than sz and RLE str this line. Okay, so till that point it will just move j to j plus plus, and the point when j is not equal to the element which is at index I, or either j goes out of bound, in that case I will come out of this while loop and I will check that, okay, what is the diff, that is j minus I, and I will append that to the new str. So if you remember, first we are appending the frequency which is diff, and then we will be appending the actual element which is caret I. So caret will give us the actual element or the actual character at that index I for the string. When this is done, I will make the I to j. This is all I am talking from the logic, so you don't need to think about a lot. It's everything happening from the logic. Okay, and then the loop will continue like this till the point the I reaches sz. Okay, so once this is done, I will be returning the new RLE str.toString, and this is how the recursion will happen again and again and again till it reaches the base condition. And at the end, I will be getting for whatever countency I have asked for. Good. Let's run this and see if all the test cases pass. Yeah, they are passing for now. Okay, your work is to submit it and see if really for all of the test cases it passes or not. It just passed for 2 test cases here, so I cannot guarantee that, but I hope that I can guarantee that the logic what I have explained you have understood. So I will highly encourage you to actually do a dry run with countancy of 10, countancy of 11, and then you can actually understand that how the logic is working and how it is actually calculating the frequency and then the actual count and appending it one after the other. So I hope you are able to understand this, and do comment out if you have any doubts, any questions regarding the same. I will be really happy to help. Thanks a lot, guys.